lead network. Lead network is a compensator basically, and when that network is excited by sinusoidal input, the output of that particular network phase angle will lead with the phase of the input voltage. This lead network is basically for improving transient performance. It improves the transient performance of the system. And lag network, it improves steady state performance. But in the case of lead network, it has some effect in the steady state, some adverse effect in the steady state, whereas lag network will not affect transient part of the response, but it improves steady state error. For that reason, in order to have both steady state and transient performance improvement, we need to go for lead lag network, and this improves both steady state and transient performance. And we can also see that lead network is a high pass filter and lag network is a low pass filter, and lag lead network is a band stop filter, and lead lag network is a band pass filter. So in terms of filters, the lead lag networks are classified in this way. Let us see the details of each and every network, what is their contribution in terms of poles and zeros, and then with the help of that we can say that how the lead network is improving the transient performance and lag network is improving steady state performance. Lead network, it consists of R and C in parallel, and then another resistance, let us call this as R1 C1 and this is R2. Say this is excited by a sinusoidal input Vi of S, then you have output V naught of S across R2. Now I am interested to know the transfer function of this lead network, V naught of S by Vi of S. So this is given by R2 by R1 and C1 are in parallel. So R1 is in parallel with 1 by SC1, Laplace transform of capacitance is SC1 plus the total resistance it becomes. Now if you simplify this, that R2 by R1 by SC1 by R1 plus 1 by SC1, the parallel combination of R and C, then the resistance R2 as it is. Now further simplification, this R2 divided by R1 by SC1 by 1 plus SC1 R1 by SC1 plus R2. So, SC1 gets cancelled. Then further simplification of this circuit is R2 by R1 by 1 plus SC1 R1 plus R2. It leads to R2 into 1 plus SC1 R1 divided by R1 plus R2 into 1 plus SC1 R1. The further simplification of this transfer function of a lead network is actually given by R2 by R1 plus R2 into 1 plus SC1 R1 by 1 plus R2 by R1 plus R2 SC1 R1. So, this component R2 by R1 plus R2 is treated as an alpha, a constant, into 1 plus this C1 R1 is treated as time constant of the RC circuit tau s by 1 plus this factor is alpha and C1 R1 is tau and s. So, the transfer function of the lead network is creating one pole and one zero at finite location. Further simplification of this is alpha take tau out s plus 1 by tau divided by take alpha tau out 1 plus s plus 1 by alpha tau. That means alpha tau and alpha tau gets cancelled. You can see now the 0 and pole are created by this lead network. So, the transfer function of the lead network is given by alpha into 1 plus tau s by 1 plus alpha tau s, where alpha is the constant R2 by R1 plus R2. This is definitely less than 1. The value of alpha is less than 1 because the denominator is more. And the another constant tau is a time constant of the RC circuit of the lead network given by R1 C1. So, now further simplification of this, if you take tau out, it can be written as s plus 1 by tau, and if you take alpha tau out, it can be written as s plus 1 by alpha tau. So, these two gets cancelled. Now, there is a pole created by the lead network at s is equal to minus 1 by alpha tau, and the 0 is located at 1 by tau, where alpha is less than 1. Now, if you see the pole 0 diagram of a lead network, pole 0 diagram of the lead network, the 0 is closer to the origin, and it is at minus 1 by tau, and the pole is at minus 1 by alpha tau. So, the dominant root here is 0, whether pole or 0, when it is close to the origin, we say that it is dominant, means it has more effect on system performance. So, this is known as dominant 0 because it is closer to the origin. So, 0 will always produce positive angle, 0 will produce positive angle, and pole produce negative angle. That is the reason why this is called as a lead network. You can remember in a simple way that if the 0 is closer to the origin, it is a lead network because it contributes positive angle to the system. So, dominant 0 it is called, and it is a lead network, but it creates 0 and pole, but 0 is closer to the origin and pole is far because alpha is less than 1 in lead network. Now, if you see the Bode diagram of the lead network, it is Bode plot consists of magnitude in decibels and frequency on log scale. This is the magnitude plot of the Bode league network, and this is 1 by tau, and this is 1 by alpha tau. And if you see the phase plot, this will be the phase plot of the lead network, and you can see that the maximum phase lead is taking place at say omega m. Then these are known as corner frequencies, omega c1 and omega c2, and if you see the magnitude m here, 10 log 1 by alpha. So, the frequency at which the maximum lead, phase lead occurs here, omega m, it is given by under root of omega c1 into omega c2, the two corner frequencies of the system will give you omega m. That means if you substitute these values under root of 1 by tau into 1 by alpha tau, this can be written as 1 by tau under root of alpha. So, the frequency at which the maximum phase lead occurs on the time constant of the system, where time constant is given by R1 and C1 of the lead network, and alpha also decides that alpha is given by R2 by R1 plus R2. So, this is the way the Bode plot can be drawn for the lead network, and we can actually see how exactly you are getting the frequency for the lead network given by 1 by tau into root alpha. So, the lead network will have a dominant 0 closer to the origin, and it will have a phase angle maximum . So, the lead network, from the Bode plot, it can be seen that the frequency at which the phase angle the phase angle or phase lead is maximum, that is given by geometric mean of two corner frequencies. Geometric mean of two corner frequencies. These corner frequencies can be obtained from the Bode plot. So that omega m is given by under root of omega c1 and omega c2. So this is given by under root of 1 by tau into 1 by alpha tau. So this is given by 1 by tau under root of alpha. Now this omega m is the frequency at which the phase lead should be maximum. So how to obtain the phase lead? Generally we have seen the transfer function of this as 1 alpha into 1 plus tau s by 1 plus alpha tau s. So if you substitute j omega t, it becomes the sinusoidal transfer function when you replace s by j omega, 1 plus j omega tau by 1 plus j alpha omega tau. So from this the phase angle function of the sinusoidal transfer function is phi, that is given by tan inverse omega t or tau for 0 minus tan inverse alpha omega tau for the finite pole. So if I want to get the maximum phase lead, I must differentiate this phase angle function with respect to omega, because at certain omega the phase angle is maximum and equate it to 0. So this will lead the phase angle phi m is equal to sin inverse 1 minus alpha by 1 plus alpha. So this phase lead is maximum at omega m, it is given by 1 by tau root alpha, where alpha is r2 by r1 plus r2, which is less than 1, and tau is the time constant of RC circuit. So this is the way the maximum phase lead given by the lead network, maximum phase lead given by the lead network is around 60 degrees to 70 degrees. And if at all more phase lead is required, then two such lead networks must be connected in cascade and get more phase lead. And the second one is, as the 0 is dominant, is closer to the origin, so dominant 0 means the damping factor or the damping coefficient zeta is more. When this is more, you can observe that peak overshoot or resonant peak, it will be less, and the speed of response, either rise time or settling time, also will be less, means speed of response is improved by the lead network because of the dominant 0 in the lead network. So in frequency domain we say that resonant peak, and the speed of response is seen here in terms of bandwidth. So overall the transient performance of the system can be improved with the help of lead network.